In this video, we're going to head back into index.js and use AsyncAwait to improve the syntax for all 6 of the routes we currently have set up. Then as we add more routes in the future, of course, we'll use AsyncAwait from the start, now that we know how it works and how we can use it. So the first thing we're going to do together is make changes to all of the user-related routes. We have post users, get users, and get an individual user. Then as your challenge for the video, you'll be converting the task-related routes to use AsyncAwait on your own. So let's go ahead and get things started up top with our very first route, and I am going to start up the server from the terminal. Right here, we can use npm run dev to start up our little development server, which uses NodeMon, and we're also going to spend our time in Postman. We want to make sure we fire off requests to the endpoints as we change them, so we can confirm they're still working as expected. Let's go ahead and kick things off by moving over to Postman and heading over to our post request for creating a new user. Now, right here, what I have is an invalid operation. We'll go ahead and change all of this in a moment. For now, let's start with some code changes to what we have right here on line 11. The first thing we need to do is mark some function as async. Remember, we cannot use await outside of an async function. That means I can't use await right here because I'm not in a function, let alone an async function. And it also means that I currently can't use await right here because while I am in a function, I'm not in an async function. So the first thing we're going to do is take this function, the one we passed to express, and we're going to mark it as async by adding async right up front like we have done a few times already. Now we know when we just add that async definition, it changes the behavior of the function. The function goes from returning whatever value you return to always returning a promise. We saw that a couple of videos ago. Now, the good news is that Express doesn't use the return value from this function anyways. At no point were we returning anything. Express does not care what we return. Instead, we use request and response to tell Express what we want to do. So in this case, we've added the async functionality without changing the behavior at all. Now though, we do want to refactor the code down below. So I'm going to take all of this code and I'm going to comment it out. We're going to recreate it using await right here. And the first thing we're going to do is await the promise that comes back from calling that save method. So that's going to be the await keyword, which I can now use since I am in an async function. And from here, the promise is available. It comes back from user.save. Excellent. So at this point, we have saved the user, and everything that comes after is only going to run once the user was saved, either successfully or unsuccessfully. Now we know the code right here on this next line is only going to run if the promise above is fulfilled. If it's rejected, as we saw previously, the rest of the function is going to stop. We saw that in the playground example. We had that 9 async await file. In here, if you remember, we had negative numbers which caused problems, and when we added them, everything afterwards never ran. We can actually handle individual errors from individual promises using a standard try-catch statement like we would with regular JavaScript code. So right here, let's go ahead and set that up. We are going to try to run this code block. If anything in that code block throws an error, we will use catch to catch it. Right here, we get access to the error using the following syntax. So what we can do is take our call to save where we use await, and we can move that into the try block. Now we can actually do one thing or another. The code right here just below is only going to run if the save promise was fulfilled. If it throws an error, the code in catch will run, so we can still do one of two things. Right here, if things go well, response.status201.send, sending back that user. Then down below, if catch does run, response.status, setting that equal to a 400, and once again, sending back the error. So right here, we have the exact same code we had down below with AsyncAwait. Now, as we do more than one asynchronous thing in a given function, the advantages we get are going to get greater and greater. So right here, we can remove the old code we have in place, and we can go ahead and do this exact same thing for our other handlers as well. Before we do, let's make sure that the post users request is still working as expected. What I'm going to do is save this file, and we're going to head over to Postman, and we'll run a few different tests. I'll send some bad data, and I'll send some good data. Right here, I have some bad data. The password is too short. I'm going to go ahead and send that off and look at the response. Right here, I'm still getting a 400, and I'm still seeing my error down below. Now let's fix that with a valid password. I'll use red12345 with an exclamation mark on the end. I'll go ahead and send that off. Now, I would expect the save promise to be fulfilled, which means I should get my 201 back. I send it off, and that's exactly what I get. A new document was added to the user's collection in the database, and I'm seeing the correct response body and the correct status code. Now that we have one of these knocked out, let's go ahead and do the same thing for the other two, then we'll move in to the challenge for the video. Right here, once again, we start off by marking this function as async, and once we have that in place, we move on down below. Now, in this case, we are getting a fulfilled value we actually want to access, unlike what we were doing up above. So we will start by setting up try catch. And once we have that in place, we'll go ahead and add some code inside of try. I'm going to try to find all of those users, and I'm going to store them in this users constant I'm defining. Right here, we are going to await the promise that comes back from user.find, calling it exactly like we had called it down below. Now, if this line of code runs, then we got our users, and we can use response.send to send them back. If this code runs, then something went wrong, and we will use response.status to set up a 500 status code, and I'll use send to send back an empty response, the status code being the signal. Right here, we can go ahead and remove the old code, and this one is now converted. We'll do the same thing down below for the last user-related route. I'm going to start by marking it as async, then we'll go through the refactoring process once again. I will go ahead and comment out everything we had before, and we'll start with our try-catch statement. Inside of try, we're going to start to do the asynchronous things we are trying to do, which is to find a user by the ID, and we're going to get them back potentially. So const right here, user equals await user dot find by ID. We are going to call that, passing in the same variable we were passing in down below. And once we have this in place, we know that things went well if this code runs. Now remember, user might not exist. If we did not find a user with that ID, this code is still going to run. It's up to us to potentially use a little conditional logic to get the exact right information back to the requester. So once again, I can choose to use an if statement. If there is no user, we'll go ahead and do one thing. In this case, I'll do exactly what I was doing down below. I can use return to stop the function execution. Then I can go ahead and use response.status, setting it equal to a 404. And from there, I'll go ahead and use send to send things off. Down below, if we did not get an empty user, then we got a real one, and we'll use response.send to send them back. Last up, inside of catch, what do we have? We have our error handler just sending back that 500. Response.status 500.send. Excellent. So now that we have this in place, we've refactored out the need to use extra callbacks for all of our functions. Now, at first, it might seem like a regression. We have code that's now harder to understand than before, but I promise that's just because it's a new syntax. We've worked with promises for longer, so that code looks a bit more familiar. Here, we are indeed using AsyncAwait, which is something a bit new, but after a short amount of time as we progress through the class, I promise this syntax will become very familiar as well, and it'll feel really natural. And as you start to create more complex route handlers, you're going to be able to do that with ease using await instead of needing to use promise chaining. So now let's go ahead and test out the second two routes we modified over in Postman, then we'll move on to the challenge. Over inside of the Postman app, I'm going to start with reading all users. Right here, I have read users. I'll go ahead and fire that off, and down below, I do indeed get my users back. Now I'm going to go ahead and also grab one of those IDs, and I'll use that ID for my read user call. Actually, I already have an ID up there, so I should be able to just send this off, and right here, I'm getting the 200, which is great. If I change the last character from a 1 to a 2, and I send that off, we now get a 404, which is correct, and there we go. We have those 3 user-related routes, and all are working as expected. Now let's go ahead and dive into what I'd like you to do with the tasks routes down below. The process is going to be exactly the same as what we just got done. Now, there's not a heck of a lot to say about this challenge. Your goal is to refactor the task routes, and step 1 is to refactor them. Step 2, test things out. Use Postman to make sure all of the requests are still working. All right, take some time to get that done. Test your work, and when you're done, come back and click play. How'd that go? Let's go ahead and kick things off with the first route. This is for creating a new task. I am going to mark that as async right here, and we are going to take advantage of that functionality down below. We'll start by setting up try catch. And once we have that in place, we can await the call to save right here. Await task.save, calling it exactly as we had done before. Now, if this code runs, we know the task was saved correctly, so response.status 201 to alert them that something was created. Then we use send to send the task data back. Down below, if things go bad, we can use response.status, setting it up to a 400, and right here, we'll use send to send back the error so we can see exactly why the task couldn't be created successfully. As an example, maybe we left off the description. With this in place, we can now go ahead and test this out or continue on to the other ones. I'll go ahead and continue on with the code and test them all out at the end. Right here, we have our next handler. I am going to convert this over to an async function, and we're going to work through that process. Once again, setting up try catch. Once we have that in place, we'll start by creating our tasks variable to store all of the tasks that we've found. Then we're going to go ahead and use await to await a call to task.find, just like we had down below. If this line of code runs, then the promise was fulfilled, and we can go ahead and use response.send to send the tasks back. If something went wrong, we'll send back a 500. Response.status 500, and right here, we'll use .send. Now that we have that replaced with AsyncAwait, there is just one more left. That is the one where we get the individual task by its ID. So once again, we need to start by marking that function as async and setting up try catch. Since whenever we run code, we want to make sure we are handling errors. It's not a good idea to just let those fly away into the darkness and not alert users as to what's going on. Right here, what are we trying to do? Well, I am trying to get a task. So I'll create that task variable, and I'll await the call to task.findById, passing in the ID that we got from the URL parameter. Now, once we have the task, we want to make sure it actually exists, and we have the code down below that gets that done. You could rewrite it, or you could repurpose it, taking it from down below and pasting it up above, as it's going to be exactly the same. Next up, we have the catch call. The catch call is going to do the same thing that it was doing down below, so we can repurpose that code as well. And finally, we can remove the old promise example. So there we go. We have all of our methods for Express relying on AsyncAwait. Now, the last thing to do was to test those 3 out just to make sure they're working as expected. I'll be removing the challenge comments first and saving the final, not saving the final, saving the file for the final time. Over inside of Postman, let's start by trying to create a task. So right here, we have that post request and we have a valid setup. I'm going to send that off, and right here, the task was created. If I were to mess that up, providing nothing for the description as an example, I would expect things to fail, and down below, they do. So from here, I can read all of the tasks. I'll go ahead and do that by firing that operation off. Right here, I can see I do have 2. Let's go ahead and grab one of those IDs so we can use it to test that last handler. Now, since we have all of this in a collection, it's really easy to navigate between everything. Right here, I'm going to swap out that old ID with the new ID. I will click send to fire that off, and we do indeed get things working down below. And once again, if I was to mess up that last character, right here, I can see I get the 404. So what we've done in this video is we've converted all of our app express handlers over to async and await. In the next video, we're going to continue on creating the other ones we need for the application. And as we create those, we'll be using async await from scratch. I'm excited to get to that, so let's jump right in to the next video.